So we talked about slope with 2 points. We talked about change in y over change in x. We said you could also do y2 minus y1 over x2 minus x1, which some of you liked and some of you didn't. Some of you liked that mini table. Today we're going to focus on graphs, which is going to be rise over run. Okay, and if you look at the graph I have right here, rise, our up and down axis, is in fact our y-axis, and our across, our run axis, is that x. So we're still doing y over x. Look at this rock climbing graph, and we're going to find the slope of the different things. Stuff I need you to be familiar with. I want you to pay attention to the scale, okay? So on our x, notice that it's actually counting by, if this is 0 and then it jumps to 50, it's actually counting by 25s, right? And then on the y, it goes from 4,000 and then it goes to 4,500. So this one is counting by 100s, okay? And that's going to be really important. We're not just going to be counting, up 1 over 2 or whatever. We have to take that scale into account. So we're going to start with looking at this WP1 to 2. I didn't label this super well because I modified this graph. So we're going to count from here to here. So our change in y, remember that's going to be our rise, and our change in x is going to be our run. So if I'm counting up, remember this is counting by 100, so my rise is 100, and my run is counting by 25s is 50. So our slope is that change in y over change in x, or that rise over run. So if we're rising 100 and we're running 50, and notice our labels, right? We want to make sure we use labels. Feet per minute. If you put that in your calculator, what do we get? It is 2, or it's 2 over 1. So this is saying that we're rock climbing 2 feet in 1 minute. And you can write 2 over 1. You can write 2. I'm putting the labels, and I would like you to do that also so you can see what it means in the context of the graph. Because they are rock climbing, they're climbing 2 feet every minute. For this next one, we're actually looking at this flat piece. I realized I didn't label it well. So we're going to go from where this blue dot is to this blue dot, and tell me, rise. That's a flat line. Yes? Are we rising any? Is my y changing at all? No. So 0, and you can put your labels here if you wanted. How many are we running? We're running not 2, but 25, 50 miles. Okay? So that wasn't minutes earlier, that was miles. I apologize for that. So rise, 0 over run. So 0 feet, 50 miles. What do we get when we put that in our calculator? 0. So that doesn't mean that 0 feet per mile. That doesn't mean that we're not moving. What that means is that the steepness, remember slope is a steepness, the steepness is flat. It's like walking on the floor here in the classroom, right? We're not actually climbing up any rocks or climbing down any rocks. It's just nice and level, easy hiking. All right, for this next one, we're gonna do the green dots. Again, I apologize, it's not labeled super nicely. So we're gonna count rise, and remember our rise, we're counting by 100s on our y scale. So 100, 200, 300, 400, 500, 600, 700, 800, 900, not 1000. What is 1000? 1,000. So we're climbing 1,000 feet. Are we running any? Did we go across any on that line? No. So 0 miles. So we have 1,000 feet in 0 miles. Let's put that in our calculator. This is undefined. Remember we talked about, so that doesn't mean again that we're not moving. Look at that line. It's going straight up and down. So you're having to use carabiners and all kinds of things. You're climbing straight up the mountain face. Okay? So now let's go with the yellow dots. We're going to go from here to here. So we're going to rise. Remember, we're counting by hundreds. 1, 2, 300. How many are we running? This is 25. 25. How many? 50. So we're going to rise 300 feet. And we're going to run 50 miles. So does that 50 over 300 or 300 over 50? 300 feet over 50 miles. What do we get? 6. 6 feet every 1 mile. And that is a positive, right? So we're still mountain climbing up. We forgot to go back and do our little lines, but you can see it on the graph as well. This one is constant, and this one was going up. All right, we got one more to look at. All right, we're gonna skip this piece right here, and we're gonna go here to here. What do you notice about that piece of rock climbing? It's going down. Now we're still gonna do rise over run, but now I'm going down. So this is gonna be a negative 25. We're going down, or not 25, I'm sorry. On the Y's, we were going 100. Negative 100 and over, now to the right is still positive 50, but because we went down, it's gonna be negative, and you can see that in your line. So negative 100 feet tells us we're climbing down over 50 miles. Tell me about negative 100 over 50. Negative 2 feet every 1 mile. So now, instead of climbing the rock up, what are we doing? We're going down. Take this information in our table. We're going to answer some questions about it. It says, what sections of the route can Thomas hike up or down? So where did we go up or down? What colors? When did we go up? We went up on the red. So we can call that section 1. Did we go up on any other sections? Section 1 and section 4. So red and yellow. When did we go down? Section 5. We went down. And we could see that not only on the graph, but also in the direction with our signs, right? Our signs tell us the direction. So which sections require ropes and climbing gear? What section or sections? Definitely section 3, because what were we doing on section 3? We were going straight up and down. Very nice. How is the slope in section 5 different than 1, or that should actually be? They what? So 1 and 4, we said were both positive. But what about section 5? It was going down. So 5 is negative, because we were climbing down. 1 and 4 are positive because we're going up. Here's some more hiking. This is talking about the calories burned per hour when we're going hiking. How many calories are burned in the first hour on a medium trail? So you're going to have to really pay attention not only to our scale, which is super important, because we're not always going to count by ones, but which graph are we using? Well, we're using this one, the medium graph. So if I wanted to know how many calories are burned in 1 hour, I can see here, here's 1 hour. How many calories is that? 500 calories. And make sure you're using your labels. How does the rate of change, right? Rate of change is the same thing as our M, our slope during that hour, compared to over another time. So if we are looking at our scale, notice we're counting not by hundreds, right? I can count up I went up 500 and I went over, it's counting by 20 minutes. I went over 1, right? So there's our 500 over 1. But what if I came up and I went all the way to this dot right here? So now I'm going up 1,500 and I'm going over 3. So I want you to think about this. If we did 1,500 calories in 3 hours, what does that simplify to in your calculator? So this is still 500 calories in an hour because 1,500 over 3 is still 500. So it doesn't matter which points you use on your graph, you're going to get the same slope every time. What about on an easy trail? How many calories did we burn on an easy trail versus a hard trail? So here's my easy trail. And you guys, you want to look for these nice, pretty numbers. Okay, so if I'm here on my easy trail, we've got 500 calories. And if you notice, this is 1/3, 2/3, 3/3, 4/3. We're going to call it 5/3. Don't write it as a decimal because it's an ugly fraction. Versus on the hard trail, I can see, on the hard trail, I have a nice pretty number here. And that's going to be 1,000 calories in that same 5/3 hours. What do you know about 500 versus 1,000? It's twice. So you're burning twice as many calories on the hard trail in the same amount of time. Use that rate of change to calculate the number of calories required for a person of average weight 4 hours on an easy trail versus a hard trail. Okay. Do you remember when we did direct variation and we made a proportion? Because we cannot see 4 hours on our graph. But we can say 500 over 5/3. This is our hours, right? And we want to find 4 hours. We're looking for this. Could we cross multiply this and divide like we did before? And the same thing here. We can make that proportion and cross multiply, divide. So when we did that in our calculator, we got 1,200 calories in 4 hours. And let me ask you, based on what we did on number 4, and we said this was times 2 to get the hard, what do you think is going to happen for the hard one? If it was times 2, is that going to stay constant? It should. What would you predict 1,200 times 2 is? 2,400. Well, let's check it with our calculator. So good job. We were correct in our prediction because that rate of change is not going to change. All right, so tell me about slope. We talked about this the other day. What does slope of a line tell you? It tells us steepness, right? How steep it is. And what? It tells us direction. Is it going up? Is it positive? Is it going down? Negative? Is it constant? Is it meaning it's horizontal versus it's vertical? What's the difference between a positive and a negative slope on a graph? Can we draw a picture? If I draw 2 graphs here and I'm going to draw a positive line, which direction is it going? It's going up from left to right. Remember, we always go left to right. And what is the negative one going? Down left to right. Okay? That's the difference. How are the slopes of horizontal and vertical different? So if this is my horizontal and this is my vertical, what do you know about the slopes of those? What do you know about the slope of a horizontal? Remember we talked about our trick. If I wrote horizontal, the O is what? 0. This is a 0 slope, meaning that it's flat. It's not increasing or decreasing. It's constant. Versus a vertical. Vertical is what? Undefined. And we said we see that in the D, right, with that vertical line. And that just means that it is going straight up and down.